primary sedimentary structures that we understood. So we would understand each of these structures under a normal phenomena and under an overturned phenomena, that is the inverted phenomena. But before that, let's understand in very simple terms syncline and anticline. So syncline and anticline we already understood when we were talking about force. So this is what is syncline, and anticline appears like A. So simply that's how you can remember it, right? So in a syncline, the young rock is at the center on the top and the old rock is at the bottom. However, under an anticline, the old rock is at the center and the young rock is on the periphery, right? So young in the center, old in the periphery, and when there is young in the center, old in the periphery, this is also called as outlier. However, when there is an old in the center followed by young outside, it is called as inlier, right? So these are the terms that you must be familiar with. We would discuss about similar terms as we proceed in the next lecture. Now, very important thing. Under the pressure and with the gravity, you see that the loose rocks got compacted and finally cemented. Now, what are these structures that we would understand and how would we identify? If there is a structure where you have rounded troughs and pointed crest, a structure like this where the crest is pointed and the trough is rounded. So trough is the lower area that is round and the crest, which is the topmost part, is pointed. This would be the case of a ripple mark. However, when it would be overturned, it would appear like this. Clear? The next is current bedding. Now current bedding, very important to understand what would happen here. It would be oblique to the main bed. So the main bed would be parallel lines on the new rock. Okay, the old rocks would be oblique. However, when it is overturned, what would happen is the old rocks would be parallel and the new rocks would be oblique. Okay, so that is what is current bedding. The next is graded bedding. Graded bedding would happen when you have coarse rocks at the bottom, bigger pieces, right? Smaller on the top, further smaller on the top, and the finest on the topmost. However, in an overturned, it would be an upright, the most finest at the bottom. Then you would have bigger particles and further bigger particles. Now note, don't get this confused with the very first thing that we studied here. This slide where you say that there is cementation. So this is old. Now this is where we are talking about the pressure. Now if there is no pressure and it's just the loose rock particle,